All right, well, hi everyone. I hope you're all having a great day. My name is Alper Gel, and I'm the Education Content Manager for CodeDay Labs. I'm very pleased to welcome Erik Kokalj, who will be presenting a special application of Luxonis's AI cameras on the PX4 autopilot drones, and also talking a little bit more about what Luxonis is and how their spatial AI technology is advancing the field of computer vision, and how you can also kind of learn more about Luxonis. So Erik, if you'd like to introduce yourself a little bit more, and then we can get started.
Yeah. Hello, everyone. My name is Erik. My fancy title at Luxonis is Director of Applications Engineering. What I mostly do is technical documentation, technical support for customers and companies to leverage the power of spatial AI into their products. And yeah, that's mostly it. And I'm from Slovenia, so I apologize for my accent. So let's start with the why Luxonis created the spatial AI cameras and the platform DepthAI. So it started with wanting to create a smart camera to save lives of cyclists. So each year, about 2,000 people just in Europe die because of the cyclist accident. And it's usually because the drivers, so for example, car drivers, are not focused on the road, mostly because texting while driving. And with the power of spatial AI, we could detect the cars and their trajectories and estimate whether they are on the trajectory towards the bicycle and warn the cyclist and the driver about this potential hit. And this could save lives. So we actually created a proof of concept consisting of stereo camera. This was from RealSense, with Raspberry Pi high quality camera connected to the Raspberry Pi, and it feeded the frames, the color frames, to the Intel's Movidius neural compute stick for AI. So it could detect the vehicles. And then with depth, it could provide the speed of the car and its trajectory towards the bicycle. So this solution, as you can see inside the box, it actually did work, this proof of concept. But the thing is, it was bulky, it consumed a lot of power, and the development cycle was really slow because there wasn't any framework that you could easily develop such solution. So that's why we created the DepthAI platform and Oak cameras. So let's first start with the competition that we have, so you'll better understand what our cameras are used for. So the main competition is RealSense stereo depth cameras. So they are actually really great. They provide a great depth. But the problem is that they only have stereo perception, nothing else. And also that they Intel end of life them last year, I believe. So compared to them, our cameras also have a bunch of different onboard features that you run on the device itself. For example, AI, computer vision, stereo depth, video encoding, object and feature tracking, object localization, Python scripting, and so on, all on the camera itself. And you can also integrate this technology into your own products with our system on module. And also our cameras are actually available, so you can buy them. So next up, let's check the software stack that we call the DepthAI platform. So at the bottom, we have the firmware that's running on the vision processing unit by Movidius. We have the API, which is used to develop applications for the Oak cameras, and it also communicates with the Oak cameras. We have the API in C++ and bindings for that in Python and Java. We also have a bunch of different open source applications, for example, face recognition, license plate recognition, gaze estimation, road segmentation, social distancing demo, and about 50 more. We also have an SDK for ease of use, so it's an abstraction on top of the API. We have AI training notebooks, which help a bunch for conversion and deployment of the models, because the models themselves, they have to be in specific format for them to be able to run on the cameras. And we also have the AI model zoo, like everyone else. So you can, these models are pre-converted, so you can easily run them on the camera. And we also have third-party application integrations, for example, with ROS, ROS2, Unity, Android, Foxglove, and so on. Now let's check the hardware capabilities. So as mentioned, in heart of all of our devices is the VPU from Movidius, which is able to run about 1.4 of TOPS for AI specifically, and you can run any AI model that you want on the device itself, even a custom architectured one. You have computer vision functionalities such as warp and dewarp, resizing, cropping, edge detection, feature tracking, and so on. You have video encoding for MJPEG, H.264, and H.265, and it's up to 4K at 30 FPS. The next hardware capabilities are stereo depth vision with filtering, post-processing, and even RGB depth alignment. We have color camera options of up to 60 FPS and up to 20 megapixels, 2D and 3D object tracking, and the cameras themselves are also quite low power. So it's below 5 watts of power at maximum workload. So everything running, for example, video encoding and AI and CD and everything. So our platform is actually quite extensible in terms of stereo depth perception, because you can use different camera sensors, which have different resolutions, different shutter types, different FPS. You can use different optics, so for the field of view, and even custom stereo baseline distance. And all of that determines the minimum and maximum stereo depth perception. So you can use our platform for very close by depth perception or long depth perception. So here on the right, there's an image with 75 centimeter of baseline distance, and you can perceive the depth of up to 200 meters. So let's jump a bit to the AI capabilities. So first of the AI vision task, we have the object detection, and we have the option to run on-device YOLO and MobileNet and on-device decoding. So the object detection provides bounding boxes of where some object is, and also the confidence, so how confident it is that it's that object. And if you combine that with depth, you get the 3D coordinates of that object. So here on the bottom, you can see, well, me and a chair and monitor, and then 3D coordinates of all of these items. And what can you actually do with this? So first you have just X, Y, and Z coordinates of these objects, for example, in robotics application for pick and place machine. So the robot hand knows where an object is to be able to pick it up. Another example is that since you know the distances between different objects, that can be used, for example, in social distancing application, which you can see here at the top. So if the people are too close to each other, you could create an application that would warn people about that. And another possible application of that is that since you have the object displacement over time, you can use that for speed estimation. So next vision AI task is landmark localization, landmark detection. So this includes the pose estimation, hand tracking, and facial landmarks detection. And you can fuse that with depth perception to get the 3D points, landmarks of these points. So for example, you can use that in a yoga trainer or just a regular fitness trainer. So it can count, so it knows where in 3D space the pose is, the human pose, so the joints. So it can count, for example, number of push-ups or number of squats you've done. Next AI, spatial AI approach is the stereo neural inferencing. So it runs the AI. So for example, in this demo, it's landmark detection for the facial features. It runs the AI on left and right mono frames, and then it combines them together with triangulation to get the displacement of the feature. So this is the red line in the middle, which is the disparity. And from disparity, you can calculate depth. And from depth and camera intrinsics, you can calculate the spatial coordinates. So X, Y, and Z coordinates. And this approach is actually very useful for features that don't have daily depth from stereo disparity matching. So it can be used, for example, to detect 3D coordinates of holes, of light sources, of objects with repetitive texture, for example, for wire mesh fence, and for very thin objects. So for example, for the tree branches, to get the spatial coordinates of all of those. Next up on the AI vision task is the semantic segmentation. So a few examples here is person segmentation, that's on the top right, road segmentation, the left, for example, for autonomous cars, and then on the right, multi-class segmentation. So the semantic segmentation classes provides class for each pixel on the frame. So for example, which pixels here are actually the road. And you can combine that with depth to provide 3D points of only the specific class that you would want. So that can be very useful in robotics navigation. So an example here would be an autonomous lawnmower that is able to only navigate around the grass areas, because it will use semantic segmentation to detect grass, and then it will use depth to get the 3D points of only the grass areas, which it will then navigate around. And another vision AI task is object recognition. So you can run the object recognition tasks on the camera, for example, face recognition, age and gender recognition and emotion recognition, OCR, so optical character recognition, license plate recognition, and so on. Oh, and these are usually combined together with the object detection. So here on the frame, it's first using object detection model to detect all the faces. It then crops the faces, and then it runs the object recognition on top of those faces only. And it's running all of that on the device itself. So here are some of our hardware examples that we have. So we have different hardware for different needs. So we have PoE cameras, so power over Ethernet, that are IP67 rated. We have IoT cameras with Wi-Fi and Bluetooth connectivity. We have cameras that have narrow baseline distance, stereo baseline distance for the close depth perception. Then we have the SOM system on modules that you can integrate into your own products. We have the Pro version, which has the active stereo and night vision. So IR laser dot projector and IR illumination flat LED. And then also the FFC line, which is the modular camera line. So you can connect different cameras to it. And here are some drone applications. So one example is for localization. So you can use stereo and IMU for VIO, so visual inertial odometry. And you can actually, and on top of that, you can then run also the SLAM, so the whole localization. Unfortunately, videos aren't playing here. Oh, too bad. So you can move around with this camera, and then it will provide the 3D mapping of the whole scene the whole route, for example. So these are quite drone-specific applications. Another one is for precision landing. So you can run AI to detect a target, and you can use that because with the stereo, you can then get 3D coordinates of this target. So the drone knows how fast it will descend to that target. Another example is emergency landing. So it's using the semantic segmentation to find all the spots, all the pixels where it can land. For example, if we want to land only on grass fields, and then the drone will move towards that because it will know where in 3D space these, for example, grass fields are, and then land safely there. Another example is, in general, in robotics, is for collision avoidance. So you can run AI with depth to get all the objects inside your collision path, and then safely move around them. And another example for just in general in robotics is a follow me application. So a robot knows where in 3D space you are. For example, you can run just a simple object detection to find a person, or you can actually run a face recognition application or person re-identification model to find you and then track you and then follow you. And just to conclude, a few key points. So on our cameras, you can run any AI model that you want and fuse those AI results with depth perception, which is called the spatial AI, and it's the key to effective robotics vision. And our OAK cameras are performant, low power, and they leverage the power of the spatial AI and CV on the edge. And you can also embed this spatial AI technology into your own products with our system on module. And just in general about Luxonis, so our business model is that we sell cameras, the hardware, and the software is mostly open source. We are a team of about 30 employees. Well, now it's more close to 40, I believe, and most of us are actually engineers. So for the future, we are looking towards upgrading our devices to the next series, which will use the next VPU. And this will be in the end of this year, which will have the 10x AI performance and also the onboard platform ARM. And our goal is to improve the engineering efficiency of the world. Luxonis was founded in 2019, and we have launched two successful Kickstarter campaigns, both raised above $1 million. So the first one was about OD, and the second one last year was about OD Lite. And in 2022, we also are launching the Robot Hub, which is a cloud platform for device management and continuous performance improvement. Oh, and that's it. Well, thanks everyone for your time.
Thank you so much, Erik, for the talk and for telling us about Luxonis and how the many wonderful ways that Luxonis's technology can be used right now and in the future. If you have any questions, please feel free to ask it in the Q&A. Maybe just one question so that people can see the interesting applications that people have been working on with these cameras. Since I know you're a very active member of the community helping people with their projects, what's the most interesting project or application that you've seen so far at your time at Luxonis?
There are actually so many across so many different industries. And every time I see a new application, I'm just like, whoa, really? You can use that in that application? So it really blows my mind when I see different applications that people have done. So a bunch of different applications were done in combination with, so we had a OpenCV AI competition. So Luxonis collaborated with OpenCV to launch that. And there were I believe about 100 different projects that were done. So you can actually check that out on OpenCVI competition results. Am I still sharing screen?
Yep,
Sure.
we see your browser right now.
Okay. 1 second. Okay, yeah, one example was for monitoring of babies that were prematurely born to be able to estimate the breathing patterns, and if everything is okay with the baby, and if not, it would call the nurses. So that was one example. Another example was for democratizing AI for applications for kids. So kids would be able to easily learn the AI. Hopefully I'll be able to share something. So that's actually, it's using Scratch to develop a simple pipeline. So this is, for example, just the face detection that's actually running on the camera itself. So yeah, here you can see a bunch of different applications, and I encourage everyone to just check them out because they're really great.
Well, those are actually really interesting. I looked at this earlier when I started started playing around with the camera, but I never saw most of these. Okay, so we have a question in the Q&A.
Mhm.
What would be the best way to get into the computer vision or AI hardware fields? I'm currently a college undergrad. And yeah, most of our audience members are currently in college with differing years, and they're looking to get into the CS industry.
Mhm.
And some might be unsure which part of the CS industry they want to get into, but
Mhm.
if as a person who is interested in computer vision as of now, like how would you suggest they start this path?
Um, So in general, in any software kind of application, even if you want to develop, for example, web applications or something like that, I would encourage people, for example, yeah, students, to just find a project that they are really passionate about. So they won't have a problem spending, I don't know, 10 hours per day on weekends to just learn about everything around that field. So that goes the same for the AI and CV.
Okay, I see. Thank you. Does
That's
anyone
actually how I
else?
got into the software development as well, and
Oh,
then
okay.
later AI and C.
Okay.
Mm.
So how easy was it for you to kind of jump between the hardware side and the software side? Since, as I said, some people are doing maybe joint EE and CS majors
Mhm.
or just CS by themselves, but they might be also interested in working on how you can implement this AI on edge hardware like Luxonis is doing.
Mhm.
So do you have any tips on that?
So actually, I also studied electrical engineering, more specifically electronics. But along my studies, I also worked as a software engineer. So first as the firmware, then also web backend, and now more on the AI and CV applications. Um, and yeah, just like the previous, I had to learn everything by myself because most of the computer science it wasn't covered on the university. So I chose a project, software project that I was really passionate about, and I just spent a lot of hours on it to learn basically everything by myself.
I see. Okay, thank you so much.
Mhm.
Um, do we have any other questions by the attendees? Eric would be a perfect person to ask anything about computer vision or maybe more about Luxonis or maybe how you could use these cameras in your own projects. Yeah, so we'll give it a couple more, bit more, and then we might wrap up.
Mhm. Sounds good.
So maybe one more thing. We've had another talk that slightly talked about how big AI and ML is going to impact the future economy, maybe short term and long term.
Mhm.
But that was mostly on kind of non-computer vision based AI and ML.
Mhm.
So do you have any opinions or maybe beliefs on how vastly the computer vision technologies of the future will impact the future economy? So maybe like job growth for people who are kind of unsure if they'll be able to find a job in computer vision by the time they graduate. Do you have anything
So
on
in
that?
my opinion, in long term, most of the blue collar jobs will just be gone because they will be replaced with machines. And AI will really be the key part to this, AI and robotics. And that's why we are also working on this, because we're trying to commoditize the robotics perception. So if you're just in general in this field, I think you won't have to be worry about the job security.
Okay, yeah. I believe that is all the questions for now. Yeah, so thank you. We'll give it one more minute until 10
Mhm.
until 40.
Yeah, sure. Yeah, and thank you everyone for listening. And if you want to get more information on Luxonis, you can check out our website, luxonis.com. If you have any additional questions, you can reach us through emails or Discord channels. We have a very active community there. So yeah, feel free to ask any additional questions there.
Wonderful. Okay, so thank you so much, Eric, for the wonderful presentation, for all the details and explanations. I really appreciate it, and for answering all of my questions and the audience's. It was really great to have you. Thank you so much.
Yeah, not
Thank
a
you,
problem.
everyone. I hope you all have a great day.
Yeah, you
Bye.
do. Goodbye.
Goodbye.